Welcome, meteorology students. Today we're going to break down some slides on the history of Earth's atmosphere. The purpose of these slides is to give you a look at how the atmosphere on Earth has changed over huge periods of time. The big idea is that the atmosphere has not always looked like it does today. The condition and state of the atmosphere has changed, so we want you to get 5 different snapshots in time as to what our atmosphere has looked like at different periods throughout time. So let's start with the present. What is the makeup of our atmosphere right now? Take a look at this pie chart towards the top here. Most of our atmosphere is made up of nitrogen. Okay, this surprises a lot of people who think we breathe oxygen. Clearly the number one gas in the atmosphere has got to be oxygen. It's not. It's about 78%-ish nitrogen. Now a distant second is oxygen, about 20 to 21% is breathable oxygen for us, and then all of the other gases in the atmosphere fall in really small amounts. Look at argon is number 3 at about just under 1%, and then almost everything else is considered to be a trace gas, meaning there's just a little bit of it there. Take a look at this chart here in the lower right. One of the things I want to point out to you, carbon dioxide, which gets talked about a lot as being a greenhouse gas that's harmful and we need to watch our emissions pouring out of the backs of our cars and buses, right? If you look at how much of our atmosphere is made up of carbon dioxide, look at this number right here, 360 parts per million, which means that it fluctuates, it changes, but if you gathered 1 million air molecules, only 360 of those 1 million would be carbon dioxide, right? So that means that there's not a lot of carbon dioxide in the atmosphere, but it does seem to have a pretty big effect. So this is where we're at now, but where did we start? Way back, right? Before the internet. Earth's atmosphere approximately 4.6 billion years ago was made up mostly of hydrogen and helium. Why is that significant? Well, those are the 2 most abundant gases in the entire universe, as a matter of fact. Most stars are made up of hydrogen and helium, so it's no surprise that our atmosphere would have had a lot of hydrogen and helium to begin with. All right? They're simple elements. They're also not very dense, which means it was very difficult to keep hydrogen and helium in our atmosphere because the Earth was hot, and when a gas heats up, it starts to rise, moves away from the center of the Earth. And so the hydrogen and helium rose to the top of the atmosphere, and a lot of it got lost into space. And we don't have it represented in our atmosphere very much anymore. It's hard to find hydrogen and helium in our atmosphere. We have to find them normally connected to other elements or molecules. So over time, what happened is something called outgassing. This is a big idea, one of the first vocab terms we've introduced to you. Hot gases that were inside of our planet started to escape. They made it out through volcanoes, they made it out through steam vents from underneath or near on the crust of the Earth. And that gas that was inside the planet starts to rise to the outside of the planet and become part of our atmosphere. And it changed our atmosphere drastically. Okay? It was no longer mostly hydrogen and helium. Now about 80% of our atmosphere was made up of water vapor. This is a long time ago. We're talking about millions and millions and millions of years. Okay? About 10% carbon dioxide and about just a few percent nitrogen. So here are a couple significant things you ought to know about Earth's second atmosphere. Carbon dioxide and water vapor are both greenhouse gases. They trap heat in pretty well. More on that another day. But if 90% of our atmosphere was made up of those 2 substances, Earth would have been a very warm place. This is almost flipped or almost opposite of what it is now, with nitrogen down here just a few percent and having carbon dioxide and water vapor much higher. Our current atmosphere looks like we've taken those numbers and almost flipped them upside down. Okay? So things began to change. Earth's third atmosphere introduces something that I want you to know called a feedback loop. For millions of years, this process right here that I'm about to explain happened over and over again, and as a matter of fact, it's still happening now. Okay? Remember we said 80% water vapor in our atmosphere. Well, what happens when you have 80% of your atmosphere being water vapor, that water vapor eventually cools down and it forms clouds. Those clouds introduce the possibility for precipitation, right, in the form of rain. And when that rain falls, it causes rivers, lakes, and oceans to form on the surface of the Earth. And if you have water on the surface of the earth in the form of rivers, lakes, and oceans, that water evaporates, goes up in the form of water vapor, and forms clouds and rain, and the rain falls into the rivers, lakes, and the oceans. And this became a repetitive process or a feedback loop that happened over and over and over again and is still happening today as part of our water cycle. Okay? As a side note, not as important, is to know that when the rain fell, it actually pulled some of the carbon dioxide out of the atmosphere and brought it down into the oceans, and it's locked in limestone rocks that were forming in the ocean at the time. So that's why carbon dioxide went from this 10% to a much lower percentage, because rain was pulling those pollutants out of the atmosphere and locking it into the ocean. And that is really when nitrogen became the big person on campus, right? It started to become the #1 gas in our atmosphere. Now, over time, the sun has had a really interesting effect on this water. Because we had oxygen and hydrogen forming water molecules on planet Earth, the sun was able to start with its energy splitting those two elements apart from each other. So hydrogen and oxygen that were bound together in water, excuse me, started to split. And the hydrogen did what it does best. It rose to the top of our atmosphere, and a lot of it got lost into space again. And the oxygen stuck around, and now all of a sudden our planet had a significant source of oxygen. And that happened because the sun began to split those water molecules. All right? Which brought us eventually, after millions and millions and millions of years, to our current atmosphere, which is where we started this whole process. Okay? We want you to know in our current atmosphere, again, know the layers of the atmosphere, the 4 major layers: the troposphere, the stratosphere, the mesosphere, the thermosphere, and then of course the exosphere, which is not pictured here. And this red line is really important. We need you to know that as the red line moves to the left, things cool down, and as it moves to the right, things warm up. You've seen this in the layers of the atmosphere slides. This is just a reminder. Know a little something about each layer of the atmosphere. Know this temperature pattern that zigzags back and forth, and know the order of these layers from the ground up. Okay? So, what are we again expecting you to know from these slides? We started off at the very beginning. Hang tight. Zoom. This is snapshot #1, information about our current atmosphere. You don't have to memorize numbers necessarily, but know what the 2 most abundant gases are. Okay? Snapshot #2. This was way back, Earth's first atmosphere. Snapshot #3, snapshot #4, and of course snapshot #5, right? These in order start like this. This is the very first atmosphere, the second snapshot, the third, the fourth, and then the fifth is where we actually started, Earth's atmosphere right there. So how will we test you over this? If you are given a description of these 5 periods of time, can you put them in chronological order? Can you state that this happened first, this second, this third, this fourth, and that the current atmosphere is our 5th snapshot? So it's a matching chronological type thing. That's how we'll test this, okay? If you got questions or concerns, please let me know.